All right, students, here we are again. And we are starting lesson 3 of our review unit. So let's see here. We're talking about proportional and non-proportional. And I know that you have had experience with this in 6th and 7th grade. So if ratios or rates of two quantities are equivalent, let's write that down here. Equivalent. Then the quantities are proportional. So we're looking for equivalent ratios. All right, if the ratios of the two quantities are not equivalent. So it's real easy here. They either are or they are not. Then the quantities are non-proportional. So those are our only options, proportional or non-proportional. I do believe in 7th grade, virtually everything that you worked with in terms of graphing and things like that, you always did proportional relationships. And that's kind of the big difference between 7th grade and 8th grade, is that we move back and forth in between proportional and non-proportional. And so we always have to be paying attention to that. All right, phooey. All right, make sure you have this copied down because I have to clear it so I can scroll up. I'm really sorry about that. So pause the video if you need to make sure you get it copied down. All right, there we go. I should have done that earlier. Okay, so here we go. Here's an example. Before we start, I wanted to put two things over here. I want you to put it in your notes. First and foremost, when we're talking about a ratio, and particularly here when we're talking of moving from just numbers into application problems, we're always going to have the dependent variable, dependent to the independent. So the dependent variable, independent, let me spell that right, always goes on top, and the independent variable always goes on the bottom every single time. So when we get more into the school year, we're going to be looking at y over x. Now I know that you remember this because last year y'all did with the constant of proportionality a lot. And if you remember, just to throw back to 7th grade, k, which was your constant of proportionality, always equaled y over x, okay? So that was the 7th grade application of it. So we're building on that here in 8th grade. All right, so Eric and Lucy ran 20 minutes on the treadmill. The table below shows the number of calories each has burned after 5-minute intervals. Complete the table and determine the type of relationship. The type meaning proportional or non-proportional. That's what we're looking at, okay? And so we're looking at, and it doesn't tell you specifically, we have to make sure we understand that from the problem, calories per minute. That means calories, remember, let's do it over here. Calories is our dependent, our minutes are independent. Calories per, and if you recall, we said that fraction bar is the word per, calories per minute. That's going to be for both of them, okay? Time is our independent variable. Virtually in every scenario that we have, time is going to be our independent variable. So that means we would do, and you remember this from 7th grade, that if you want to figure out if something is proportional, you do y divided by x, just like we had right here. Okay, so we can come back to this idea. That means we would do 70 divided by 5, which would give us, in simplest form, our unit rate, 14:1, 14 calories per minute. And so if we do this every time, then we're going to have 140 divided by 10, which is 14:1. And we're going to have 210 divided by 15, which equals, remember, you can use your calculator for this first unit because it's not we're not testing your ability to do arithmetic. We're trying to reactivate the things that you learned in 7th grade. And then again, 280 divided by 20 gives us 14 to 1. So Eric, for each one of these 5-minute intervals, he burned 14 calories per minute. Let me go ahead and write my units here. I put a P there instead of M. Calories per minute, calories per minute, calories per minute. Okay, let's go over here then to Lucy. And let's look at it a different way. So here we notice we can do 5 times what number to give us 45? Times 9. Okay, if we did our division problem, y divided by x, we would have 45 divided by 5, which is 9 calories per minute, per 1 minute. And then if we do 10, another way to look at it is 10 times 9 gives us 90. If we divided, we would still get 9 calories per minute. See how we wrote it a different way, but it means the same thing? But then we look at this one. 15 times 9, if you do that on your calculator, you're going to find that it does not equal 120. It is 15 times 8. Ooh, which means if we did 120 divided by 15, we would get 8 calories per minute. Okay, so really, for all intents and purposes, you don't have to do this next one. It's easy. 20, of course, times 9 is 180. But we don't need to do that. Once we notice that this guy right here is different, these are not equivalent. 9, 9, 8. Those are not the same. So we can quit right there because now we have the information that we need. It says determine the type of relationship. Okay, so this is, again, 9 calories per minute. All right, so we can say the calories burned by Eric is proportional. Let's write that down. To, okay, let's stop right here for 1 second before I finish that sentence. It says calories to time. That tells us immediately how to set up our proportion, how to set up the ratio. It means, it tells us right here, calories per minute, calories to time. Okay, so if you're reading the questions and paying attention to how they're phrased, you can make sure you're setting up your ratios correctly. All right, because the rates are equivalent. You can say the same, you can say equal, all of the synonyms that mean equivalent. All right, the calories burned by Lucy, again, it says calories to time. Let's just say R. Okay, anyway, non-proportional to the time because the rates are not equivalent. Rates are, I'm going to put not equal. All right. Okay, so make sure, especially over here in these notes, make sure that you have all of this written down. That's a bummer. I shouldn't have written that. These two are key ideas. Okay, this is going back to 7th grade, but these two right here, man, that's going to be so important for the 8th grade curriculum. All right, so make sure you have all that copied down because I got to clear it and scroll up. All right. All right, so we're going to look at this one. Okay, so determine whether the quantities in each table represent a proportional relationship. If yes, give the constant rate. Okay, remember we said that it is going to be y divided by x, okay? So the buses hold a finite number of people. All right, so that's going to be your independent. The number of students is what may change. So that's going to be students over buses, okay? So we have 24 to 1. And we're checking to see, does that equal 45 to 2? That's what we got to figure out. Well, if you're noticing from your that's an ugly color. From your elementary years, you can do equivalent ratios. How to get from here to there? Well, times 2. So we'd have to go up here, times 2 as well. That's that multiplicative relationship. Is 24 times 2, 45? No, it is not. So right off the bat, we know that this ratio right here does not equal this ratio right here. So what can we say about this? Is it proportional? No, it is not, because there is no constant rate. Last year, that constant rate of change that we're talking about makes it, I shouldn't really say that. Okay, but constant rate of change makes it proportional in this instant. Okay, all right, here we go. Oh, y'all can do number 2 by yourselves. Okay, that's all we're going to have for this video then. Drawing on looking for equivalent ratios, proportional versus non-proportional relationships. Remember, your calculator is your friend here, so don't be afraid to use it just to check your work. Even if you can do the things mentally, just make sure you check your work. Always, we say in 8th grade math that you use the tools available to you. I'd hate for you to get something wrong because you were trying to do it in your head when you could have had a calculator. All right, there we go. Done with that one for today.